Thank you. Hello, hello, hello. Hi, everybody. Let's see if I can get this these slides up here. OK, so just to preface this talk, so an interesting thing happened last night. I was at the hotel, and I brought this along, which is an actual Nintendo. And I have one of these cartridges it's called an EverDrive. And basically what it has, it's hard to see, but in the top right here, it's a little slot that takes a SD card that you can pop out. And basically, you can load your programs onto here and run it on the real hardware. So I thought, OK, cool. I got my presentation done. And I'm going to test it out in the hotel room. So the AC adapter is as old as the machine. It's like 30 years something old. So I plug it into the outlet, and it goes pop. And the lights go out in the hotel. And so I had to go down to the main desk and come up and tell them, hey, the power went out in my hotel room. I don't know what to do. So yeah, so they came up, and it was just a circuit breaker that they switched on, and it worked again. But the unfortunate thing is I fried the AC adapter. So I can't actually use the Nintendo. But I have a laptop that runs an emulator that will work. So we should be OK. And I filled in some slides that I made in like a couple minutes. Anyways. Hi, my name is Michael. I'm going to be talking to you about hacking your Nintendo with JavaScript. And when I say this is about hacking your Nintendo with JavaScript, I really mean that this is a story about the impossible. And OK, maybe not impossible, but I thought it would be impossible when I set out to do it. And that's important, because just when you think something is impossible, it shouldn't stop you from trying. And what often seems impossible is just usually the lack of knowledge in our brains. And even when it's not impossible anymore, it could seem like such a large task that it's overwhelming, and it will like create a barrier to even trying anything. So all this Nintendo stuff, it took me a long time to learn what I'm going to share with you today, but it was super exciting and fun and not impossible, actually. OK, I'm kind of getting ahead of myself. So while I'm giving this talk, I also kind of want you to think about something that you would love to build. And maybe you've put it off because it seems like an impossible task. But like maybe you want to build an operating system or write a compiler, something like really, really big. Or maybe it's like something smaller, like writing a bot or building a web page. And those are great places to start, too. But those aren't impossible tasks, and you can actually do that. And like as a side note, there's intermezzos. Like I was really interested in operating systems, and this is a really cool project that like helps you to understand how to build an operating system like step by step. And yeah, it's awesome. You should check it out. Anyways, it's not impossible to build an operating system. You can do it. So let's get back to Nintendo stuff. So the very start of this project was 4 years ago when I was sitting at a bar at JSLA, which is this local JavaScript meetup that we have in Los Angeles. And I made some pixel art for this. This is actually a Nintendo program that should be running on the actual console, but it's not because I broke it. But it's running in an emulator. So I made my friend Evan helped me like make some of the pixel art, and then I kind of like filled in the colors and stuff. But so this is compiled down to assembler and assembled into a Nintendo ROM, and it's running on a real emulator, but it will run on a real Nintendo. I've tried it before, and it works. Anyways, this is supposed to be me at the bar, chit-chatting with my friends, I guess. And so we're at the bar, and we started talking about these 8-bit style like video games that we grew up with. And we were discussing the pixel art style, music, and just like how great everything was. So somewhere in the middle of all that, I mentioned like I don't really know how this stuff works, but I know JavaScript, and I thought it would be cool if you could write JavaScript programs and have it run on a Nintendo. And so the idea really intrigued me, but I had no idea where to start, so I didn't do anything for a while. I just kind of like let the idea sit. But it would often come like back to me like in the middle of the night or something when you're just like really quiet and those thoughts bubble up in your brain. So eventually, like I tried it. I tried to do something about it. And looking back on it now, I made like a lot of mistakes along the way, but they were like learning mistakes, and I think they were necessary. And I have the luxury of like looking back on a project that I made mistakes on instead of having something I never tried to do. So my first step was like to read the entire internet. So I read like everything about the subject. And the cool thing about the internet is you can find almost like any information that you want about something. And this is especially the case for a console that came out in the early 80s. So I read about how the processor in the Nintendo is the 6502. It's a processor that Atari used. It's the same processor as the Apple II and the Commodore 64. So the internet gave me this huge, like vast cornucopia of forums, text files, online tutorials, and websites devoted to information about what I wanted to know. And there was so much information to take in. There's detailed descriptions of how graphics worked and how sound was created. And I'm super grateful to all those people that on the forums and stuff that left their notes, because it's not like you can go into a library and buy and like rent or check out a book about like how to write a Nintendo program in JavaScript. They just doesn't exist. So you kind of have to, like, the only place to find this information is like the deep comment links on some forum thread from the mid-90s. So when you have a processor, you have an assembler. And with the help of the internet, I wrote a couple Hello World type programs in assembler, basically just like getting text to the screen. And I actually got them working, and I was super happy. I've been writing programs for, I think, 18 years now, and I never get tired of that feeling when you write your first like Hello World program, even if it's not Hello World, even if it's just like doing something with graphics and it's something super simple, but it like clicks and it makes sense. So after completing the Hello World program, I started writing this program that I called Nestle. And Nestle was a program that would take some JavaScript that you had written, and it would compile down to assembler, and you would then like use a 6502 assembler to make that into a binary. And to be completely fair to myself at this point, it was not great code. Like, it was very hacky. It wasn't very useful in writing programs. It wasn't really a compiler. It was just some functions that helped like output some boilerplate assembler that you still had to deal with. But as also a part of that fairness, I should say that I had never really done any of this before. I'd never written a compiler or anything, so I had no idea what I was doing. But thanks to the internet, I did go through some tutorials about how to actually write a compiler, and I learned a lot from doing that. So I learned more assembler, and in order to see what parts of the assembler could be abstracted out, like knowing that assembler was really helpful. And I needed to learn like the shape of a thing before I could start taking the pieces apart. So let's see, let's do some demos. I think, let's close that. Sorry, it's kind of janky way to do demos. Okay. Okay, oh, there's just some information about it. I've already said some of this. Came out in 1985, 8-bit console. CPU is a 6502, 64 kilobytes of memory. PPU that does graphics. The APU is the audio processing unit, has 5 different channels. We can go over that later. Let's do a real demo that's not text. Here we go. Okay. So this was like one of, I think this was the second demo that I did. And what it is I'm using Nestle to take the Super Mario sprite sheet and display the sprite for blocks like over and over again in 3 rows. And then I have a Goomba not quite in the middle over here. And then I have this like little hexagon thing that I drew that's not very good and should be green, but it's not. I tried to make it green, but there was a bug in like the columns, so that's why some of the blocks are green, and I never figured it out, so I didn't, just whatever. But I can move this Goomba around, and like the Goomba actually like moves around. This is not like a web browser either. This is on a Nintendo, so just keep that in mind. Even though it's on my computer, this is running in an emulator on a Nintendo. So this was cool. I was pretty proud of this. So yeah. So at this process of the project, it led me to being able to run my demos on an actual Nintendo, like that demo would run on this actual Nintendo. And so these demos allowed me to load sprites, get controller input working. I can move the sprites around like you saw with the Goomba. And I was able to abstract out a large amount of the boilerplate assembler that could be generated in function calls in JavaScript. So far I've made a great progress. I've learned an incredible amount of information. I've completed a lot of the tasks that have been necessary in completing my goal, and I'm happy with my success. But I think it's important to point out that at this point I've kind of failed at what I set out to do. It was supposed to be a language that helped you write Nintendo programs, and it wasn't that. But I was overall happy with my success because it kind of pushed me to go further. I think one of the reasons why it failed was that I really hadn't, it was like too big of a step, and I hadn't really learned everything that I needed to yet. And so while I was working on Nestle, there were certain things that popped up that I wanted to be able to do, like edit and create my own sprites instead of just using like the Super Mario one or whatever that I found on the internet. So the ability to do that would get me closer to my actual goal. And well, I read about how graphics worked on the Nintendo. I didn't really fully understand what was required to edit them and then load them back into the ROM. So I continued to read and learn, and I took the information I read about Nintendo headers on the actual ROM. They have like a header file or a header chunk, and I used that to figure out the block sizes and the memory locations of the sprite data and the program data. And after learning all that, I wrote a module that I named Nestle Split, and basically what it does is it reads the headers, parses out the relevant data that you want to separate in the file, and allows you to write that data out. Like you can just pipe it to a stream or whatever. So using Nestle Split, you could take the actual Super Mario cartridge or a ROM that you found on the internet and pass it in, and you would get the sprite data, and you could load that sprite data into a sprite editor and change pixels around, and it was awesome. So this was great. This was super helpful for developing, because I could just take Super Mario, and if I wanted to change it the way his mustache looked or whatever, I could. But it didn't get me as far as I wanted to go, because this worked fine if you were using your own sprite file that you created in your own program. But if I wanted to take Super Mario, change the sprites, and then load them back in, I couldn't quite do that yet. So I wrote another module called Nestle Meld, and it does kind of the opposite of Nestle Split. What it does is it takes a ROM and a sprite file, and it merges it back into the right memory location. And it can figure out exactly where it needs to go because of the headers again. And it also will know how big your buffer is for your sprite data, and then it can just write it directly to the ROM. Cool. So this all happened very quickly, and in months, I had gone from not really understanding anything about this piece of hardware that I'd used since I was 4 years old to knowing the specifics in such detail that I could write software to rip out and replace sprite sheets. I could assemble programs and display sprite sheets, and I could even move those sprites around with one of these things, the Nintendo controller. I could make like the B and A buttons do things, and the directional pad, and all that stuff. So I gave a talk at the local meetup, and I did a talk at JS Fest in San Francisco, and it was really cool. I was really happy and pumped up about it, showing people all these tools that were written in JavaScript and could do cool things with your Nintendo. But then I got sort of burnt out by it all. And after after those first couple months, I didn't code anything related to the project for a long time, probably over a year. And I think this is totally fine, because there are times when you are doing like these really cool things that might be hard or whatever, and they're fun for a time, and everything's flowing, and then abruptly progress stops. And it's, maybe you got burnt out, or maybe it just isn't fun anymore, and you take a break, and you take a long break, and when you take that break, you can come back to it later, because if it really interests you, then one day you'll have the urge to get back to it. So after a while, I still had ideas that I had never really accomplished. Like, I really wanted to, when I was making Nestle, I really wanted to do sound. There's actually a GitHub issue that I opened up for myself, saying like, oh, reach goal, get sound working or something. But I didn't really look into it that much, because it didn't seem possible, or it didn't seem like I would be able to get it working in the time required or whatever. So I focused on the graphics. It had taken so much effort to figure out how to get graphics working, that I didn't look into the details of how sounds were generated. And I wish I would have, because it turns out that sound was much easier to get the graphics working, and they were way more fun. So I started reading on the internet how sound was created, and I found a forum thread that went into detail of making a sound engine in assembler for the Nintendo. And this was great. I read every single post. I did all the assembler exercises. And each step of the way, I did every single exercise to get it working, because I wanted to learn how to do this. And at the end of the form, like if you went through every single comment, at the end of it, you had this sound engine and could define these sound files that would be fed into the engine and produce these crunchy 8-bit noises, and it was amazing. But although you were writing these sound files, it was a good abstraction for assembler. You were still writing assembler, so I wanted a JavaScript API. So I started ripping apart the sound engine and making parts of it dynamic. And then I made another module called Nestle Sound, which basically gives you, like, this is the API right here. It's pretty simple. It's just like you get song, dot, and then it's chainable, and then your instrument, you pass it an array of notes with octaves. You get four channels, 2 square, a triangle, and noise. And you can make sounds on your Nintendo with it. So I ripped apart the sound engine, made parts of it dynamic, made Nestle Sound, and the output of Nestle Sound generated a build folder with the necessary files to assemble a program that would run on your Nintendo and play music, or sounds. You can make sounds for video games, or 8-bit music, or whatever. And I tried to incorporate most of what I learned in the process of going through the forum post in the actual API. For example, I wanted to make it easy to create sound envelopes, or volume envelopes, or change the duty cycle, or change the timing of the note. So I made a JavaScript API for all of these things. And this was much easier to write than the graphic stuff I started working with, and it was more fulfilling. Like, I spent like hours and hours like playing with it and making music and stuff, and it was really fun. Yeah, let's see. I'm going to do some music demos now. So this is just like the square channel. Oh wait, I don't have audio. How do I do audio? Hello? Un momento, por favor. Awesome. So this is a square channel, and I'm just kind of going, playing, I think, a C note and just changing the octaves. So yeah, so there's a square. And then this is what a triangle sounds like. It's more bassier all the way up to like fluty sounds. And then like I started doing like arpeggio stuff, and this was actually the first little like musical thing that I did, I think. Okay, that can get the idea. So then I thought this was really cool. Oops, I think I just locked my computer. So I had these features and stuff, and the volume envelopes are really cool. You could do like staccato and blip echoes and all sorts of stuff with them. They're really cool. But then I went to go speak at JSConf about Nestle Sound, and I started learning music notation, and I started transcribing music, and I was trying to find like good music that would translate well over to like a monophonic device, because you can only play one channel at a time. So, or sorry, you can play. You can only have one channel going at a time. So you can do things like tricky with like timing and stuff, but you have to be careful about how you write your music. But I found out that Bach actually is really good for this, because he writes a lot of things with like only one or two voices. So I transcribed. I don't know what this is called. It's BWV 847 for anyone that's a classical music nerd. But here. Okay, enough of that, because it keeps going on. And then this one's really quick. This is another Bach one. It's BWV 851, if you're following along with the Bach notation. And it's shorter. And I didn't finish any of these because they're like sheets and sheets of music, and it was. So then I did, another one was the Super Mario theme song, but when I was transcribing it, it wasn't coming out quite right, so I was like, I'll just put remix after it, and here it is. Okay, anyways, let's see, I'll do one more. Are there any metal fans in the crowd? Yeah. Slayer fans? Yeah. All right, it's gonna be really boring, but I did Raining Blood by Slayer. That's the whole song. It's like just, this is it. It's just like drop D, like that's it. Except that part. And then it goes on and on and on. Okay, so yeah, so I did all that, and I had some ideas on where to go next, but they seemed very hard to accomplish. The big problem with Nestle Sound or any of these modules that actually compile down to the assembler itself was that you still needed an assembler to actually assemble the program. So this meant like installing a separate program, usually written in C, C++. I'd usually recommend NesASM because that's what I was using, and this was annoying because it was something else you had to, it just didn't happen automatically, right? You had to install this other program and deal with the build folder and stuff. It's super annoying. If we had an assembler in JavaScript, the entire tool chain would be in pure JavaScript, and it would be able to run in Node or the browser. And this is what I wanted, and so something I thought a lot about. And like, I took a break for like another year. But at some point along the way, I found a package called NodeConf, and it's written by this person, Guto Maya. And this is a really cool piece of software. It allows you to edit sprites, input source code, assemble. It had an emulator running, so you could see the source code like assembled and the ROM that it generated. And it's all running in the red browser. It's really cool. So I just wanted the assembler part of the tool chain. So I talked to Guto and I told him that, and he gave me some pointers and stuff. And he's done like really great work in the retro video game space in like Python and Node and stuff. You should check out his projects. So I ripped out his assembler and I made a new module called Nestle Assembler so that I can install it on NPM and just use the assembler part. I made a bunch of changes to it and molded it to kind of fit my needs and into a tool that I could use for like Nestle Sound and stuff. I should have changed the slide. So I've been working on this for a while, and I got it working with some basic examples, and I was really happy when I got it working. But the problem was I needed to change some of the stuff in the parser, and the parser was a lot of regular expressions. So I took a break from Nestle Assembler once I got like the basics working, and I set out to write a 6502 parser. So at this point, I should point out that I, once again, had no idea what I was doing. I had never written a parser before, and really anything related to compiling, assembling, parsing seems like magic to me still. So I needed some help. So luckily, I came across like this library, this parsing library called Mona. It's written by Kat Marchand. And it allows you to write these little parsers for specific things and then reuse and compose them together into more powerful parsers. And it's a really great library. I'm grateful that it exists, and I'm grateful to Kat because I asked her a bunch of questions while I was writing this. She was super helpful. So using Mona, I wrote this module called Parser 6502. And it will parse your assembler and give you back an AST-like structure. And you can use that to do whatever you want with it. And I'm going to eventually use it in Nestle Assembler to replace the regular expression parser. I haven't done that yet, though. So anyways, this is the progress that I made so far. It's taken me about 4 years to get here, but in the process, I've written a bunch of modules, a sound engine, a good chunk of an assembler, a parser, and I've made some mistakes and I abandoned some ideas, but I learned a ton in the process. And I still have ideas from years ago that I eventually want to see exist, and now that the entire tool chain is in JavaScript, a lot of possibilities are opened up. I mean, we've seen some stuff today that I think could go hand in hand, right? I mean, imagine the things that can be built. The entire platform of Node with modules on NPM. You have the entire browser API. We have web audio, WebRTC, WebTorrent, emulators in the browser, assemblers in the browser, tons of other things all working in the browser. We have frameworks like Electron that allow us to build cross-platform desktop applications. It's possible to now build an application that works on almost anything, where you can create sprites, music, sound effects, code, emulate, share with all your friends through like WebTorrent, using all one desktop application. You could export it and even run it on like real hardware if you don't blow up your AC adapter. You could write a MIDI interface to it, hook it up to the sound engine, have it write real Nintendo music using a real instrument. Running on real hardware. So this is all possible now, and I don't have any idea where to begin, but yeah, I'm grateful that all this stuff exists. So anyways, that's my talk, and thank you for coming. I do have like one last slide, I think. Yeah. If you want to come talk to me later, I made this Twitter bird pixel art, and yeah, I'm on Twitter. If you see me in the hallways and have questions, just come up and ask me, and I'll chat with Nintendos about you. Thank you.